Today, I would like to discuss a highly significant topic for people living in contemporary capitalist and technological civilization: the relationship between art and the lives of modern humans. The term art is widely used in our language and can encompass a broad range of things. For instance, certain crafts produced by artisans are also referred to as art. What distinguishes a craft from a work of art? This is an important topic that the philosophy of art seeks to explore. The term art has even broader applications. For example, the art of management or the art of leadership are metaphorical expressions that have no direct connection to human spiritual activities, with philosophy, religion, and art being the three highest forms. Science can be considered as a subsequent category. Science emerged as a distinct discipline from philosophy, and great scientists engaged in exploration and scientific creation require an artistic mindset. This correlation between science and art may come as a surprise to many. When we discuss scientific research, our focus is often on rational thinking and the application of logic, which is highly abstract. For example, theoretical physics is highly abstract, and the frontiers of theoretical physics are discussed using extremely abstract physical concepts. So physics and art may seem unrelated at first glance, but they are, in fact, closely connected. We are all aware of the physics revolution initiated by Albert Einstein, which was prompted by a crisis in physics. The occurrence of this crisis during the latter half of the 19th century was primarily due to the study of thermal radiation phenomena. It was discovered that the study of thermal radiation phenomena could not be reconciled with the central paradigm of Newtonian physics. The pivotal discovery that led to this realization came from Max Planck's formulation of quantum laws. In the field of physics, experimental physicists work in the laboratory, where they explore and occasionally make significant discoveries about new natural states that have not been previously observed. When they study thermal radiation, they record the experimental results and write a report on the experiments. Physicists can be classified into two categories: theoretical physicists and experimental physicists, each with their own roles. Experimental physicists conduct experiments in the laboratory and sometimes make groundbreaking discoveries about new natural states that were previously unknown. They then write experimental reports, which they submit to theoretical physicists. The role of theoretical physicists is different. They do not perform experiments themselves. Instead, they engage in idealized experiments or thought experiments conducted within their minds. They do not enter the laboratory. When experimental physicists submit their experimental reports to theoretical physicists, the latter take the experimental data about the natural process and try to successfully incorporate it into mathematical formulas. If they succeed, a new law or principle of physics emerges. However, if they are unable to fit the experimental data into a mathematically rational framework, the theoretical physicists may say to the experimental physicists, the so-called new natural state you discovered simply does not exist. Please re-examine your experimental process. In this way, the collaboration between experimental physicists and theoretical physicists involves a back-and-forth process of experimentation, data analysis, and theoretical formulation, ultimately aiming to uncover the underlying principles governing the natural world. On that day, a good friend of Planck, who happened to be an experimental physicist, visited him with great excitement. In the afternoon, he knocked on Planck's door and was welcomed inside. They sat in the living room, sipping coffee, and the experimental physicist eagerly said to Planck, "I have discovered a new state, a natural state, in the laboratory. I have brought the data and the report with me." Planck smiled and replied, "Now I have some work to do." Planck subsequently spent some time and eventually succeeded. He successfully incorporated all the relevant experimental data regarding thermal radiation into a mathematical formula, which is now known as the quantum laws. It turned out that the propagation of energy is discontinuous, released in discrete packets called energy quanta, or simply, quanta. This is how the quantum laws emerged. Subsequently one day, Planck's son took a walk with his father in the garden during twilight. The son congratulated his father, saying, "Thanks to your discovery of the quantum laws, you will be remembered in the annals of physics." However, to his surprise, Planck's face turned gloomy upon hearing these words. He said to his son, "I would rather not have discovered this law because its discovery fundamentally changes our understanding of the foundations of nature." Thus, he expressed his preference for not having made the discovery. Therefore, the discovery of the quantum laws was like a dark cloud appearing on the horizon of physics. Originally, the sky of physics was clear and vast due to Newtonian physics, which had provided a comprehensive understanding of the physical basis of natural phenomena. People believed in Newtonian physics and thought that the future development of physics would mainly involve the extension of Newton's principles to different branches. Newtonian mechanics served as the axiomatic system of Newtonian physics, resembling mathematics. It provided a foundational system, and its principles were applied to various fields, such as thermodynamics, resulting in the development of fields like classical thermodynamics. Now, a dark cloud is rising on the horizon of the physics sky, and it is growing larger, approaching closer to us. Why did Planck say he would rather not have discovered this law? Because the quantum laws cannot be reconciled with the central paradigm of Newtonian physics. Every theory and academic discipline has its core thinking, known as a paradigm. The central paradigm of Newtonian physics consists of two fundamental concepts, the pivot and the force. Now, with the advent of quantum laws, what do we do? At that time, several physicists in Europe took their own lives. We couldn't understand why they would commit suicide. In reality, it was because these physicists had invested their entire lives' value in a system of truth, Newtonian physics, which was now on the verge of collapse. Hence, they would rather not live to see it anymore. What did Planck do then? He made efforts to unify the quantum laws with the central paradigm of Newtonian physics. Subsequently, Planck dedicated 11 years of hard work, but ultimately, his efforts ended in failure. Regarding these 11 years of failure, Planck said, "I have learned a lot from my failed efforts during these 11 years." It was a comforting statement, but there was another person who did not want to undertake this task, to unify the quantum laws with the central paradigm of Newtonian physics. Instead, he initiated a revolution in physics. What is a revolution? It is a paradigm shift, transforming the paradigm of Newtonian physics into the paradigm of relativistic physics. This is a revolution. Every revolution is a paradigm shift, and this applies to any field. In the realm of social life, it is called a social revolution. For instance, the transition from feudalism to capitalism represents a transformation of the central paradigm of a society. However, this topic is beyond the scope of discussion here. The paradigm of relativistic physics replaced the paradigm of Newtonian physics. However, Newtonian physics was not invalidated, it became a part of relativistic physics. All the formulas of relativistic physics can be transformed, when necessary, into the formulas of Newtonian physics. On the other hand, the formulas of Newtonian physics cannot be transformed into the formulas of relativistic physics. The latter encompasses the former. Newtonian physics, which describes the macroscopic universe, has become a component of the entire field of relativistic physics. Relativistic physics encompasses both the macroscopic and microscopic realms, with the microscopic universe referring to the spatial domain of fundamental particle movements. When comparing these two branches of physics, Newtonian physics can be considered a special case within the macroscopic domain of Einstein's theory of relativity. This represents genuine progress, as the latter encompasses and expands upon the former. It signifies a revolutionary advancement in the field. Why was Einstein able to initiate and complete this revolution? We might attribute it to his exceptional capacity for rational thinking. While that is certainly true, rationality alone cannot accomplish a revolution in a field. What is required for a paradigm shift in physics? It demands immense imagination, intuition, and insight. Let's take an example. We are currently sitting here, not flying up into the sky. Newton also observed this fact when he saw a ripe apple falling to the ground. Why does it always fall to the ground instead of flying upward? It is due to the law of universal gravitation. We now understand and accept that the reason I'm not flying upward is because of the gravitational pull exerted by the Earth, which has a center of gravity. Now, let's reframe this understanding. The reason I'm not flying upward is because I am being pushed down by a tremendous field, keeping me grounded. This provides an alternative explanation for why we don't fly upward. In the realm of relativistic physics, large-scale space is considered a field. Gravity does not arise from a single pivot point but from a field. This revolutionizes our understanding. To complete such a revolution in physics, what is needed is immense imagination, intuition, and insight. It is not purely a matter of logic or rationality. Let's start today's topic from here. Our official slogan for many years has been promoting the phrase, "Innovation is the source of national progress." I strongly agree with this statement that innovation is indeed the source of national progress. However, after agreeing with this statement, we need to further question what the source of innovation is. Let's assume that we are in a state of intellectual freedom. Can we truly innovate? Certainly, freedom is a necessary condition, but it is not a sufficient condition for innovation. Do you agree with this point? From a logical perspective, it is clear that a necessary condition is not equivalent to a sufficient condition. So, in response to this statement, I would add another phrase: innovation is the source of national progress. And what is the source of innovation? Xing Ling. I believe that is a concept in Chinese culture and does not have a direct translation in English. It represents a unique aspect of Chinese thought and philosophy that encompasses more than just imagination and intuition. It includes a sense of deep understanding or insight that is difficult to translate adequately into English. During my conversation with the British philosophy professor, I mentioned Xing Ling as the highest capacity of the human mind according to Chinese thought. The professor asked for a translation, and I initially suggested imagination. However, I recognized that Xing Ling encompasses more than just imagination and intuition. It also involves a sense of deep understanding or insight that is challenging to capture in a single English word. I explained to the professor that there is no direct translation for Xing Ling in the English vocabulary, indicating that this specific concept is absent in British thought. He was quite perplexed and somewhat discouraged at that time. However, later on, I thought of a different approach. I wanted to explain to him that the Anglo-Saxon culture also has an extraordinary artistic history. I acknowledged their great sculptures, architectural works, musical compositions, paintings, and even mentioned Shakespeare in literature. Then, I posed a question to him: which capacity within the human mind is responsible for the ability to create artistic works? Is it sensibility or rationality? Many of us have studied some philosophy, perhaps during our high school years. In Marxist philosophy textbooks, there is a concept of two stages of human cognition, the lower stage of sensibility and the higher stage of rationality. You may have heard of this. There are two leaps, one from sensibility to rationality, which is the first leap, and the second leap is from rationality to practice. According to our epistemology, as described in textbooks, this is how it is presented. Western thought also generally follows a similar epistemological framework. Sensibility and rationality are considered the primary stages, with rationality being the highest capacity of the human mind. However, in Chinese thought, Xing Ling is regarded as surpassing rationality. It encompasses imagination, intuition, and Ganwu. Why is it difficult to translate Ganwu into English? It is because Ganwu refers to the process of moving from the particular to the general. Can you perceive universal aspects from individual things? When we study science, we typically move from the general to the particular. We first understand the general principles and then apply them to specific examples to solve problems. This is known as moving from the general to the particular. But can we also do it the other way around? Yes, we can. This ability is called Ganwu, which involves perceiving the infinite from the finite, the general from the particular, and the universal from the specific. Then I continued to explain to the British philosophy professor that an artistic work is neither created by low-level sensibility nor by high-level rationality. If high-level rationality alone could create an artistic work, Wang Defeng would have been an artist long ago because I possess strong rationality. I had studied Hegelian philosophy extensively. Take a look at Hegel's philosophy of logic and read his Phenomenology of Spirit. The logic in the Phenomenology of Spirit is highly abstract, and the deduction of categories is extremely rigorous. In the past, I could write poetry, but later, while studying philosophy at Fudan University from my undergraduate to doctoral studies, my thinking became entirely rational, and I could no longer write poetry. I truly lost the ability to write poetry. Eventually, I managed to write a few poems, but they were filled with abstract concepts. They ended up being a collection of words, with a heap of concepts piled up. Although they rhymed, they were merely a collection of words. When we encounter an artistic work, what can we obtain from it? For example, let's consider landscape painting. If it depicts mountains and rivers, a bridge, and a boat beneath it, you see all of these specific and concrete images. However, if this painting possesses true artistic value, you will perceive infinite elements within the limited and specific images you see. Do you agree? This is known as huajing, a term used to describe the state where you go beyond the initial visual perception and enter a realm of infinite possibilities. Chinese people have a saying that goes, "Good artistic works are always like this. Words may be limited, but meaning is boundless." The artistic conception is infinite and profound. Now, let me ask, what kind of power within our minds creates a painting that can lead its viewers into an infinite and profound realm under the guidance of its imagery? Is it perception or reason? No, it is Xing Ling, which encompasses imagination, intuition, and Ganwu. We have a term to express this, Xing Ling.